Hello everyone, welcome to my channel. In this video, we will be seeing how to interface a 4x3 keypad matrix along with a 16 cross 2 LCD with STM32. In previous videos, in part 5 and in part 4, we have seen how to interface a 4x3 keypad matrix and 16 cross 2 LCD separately. In this video, we will be seeing how to interface them together. So steps for programming will be first six as always said, these are the same: enabling clock, resetting the GPIOs, configuring the GPIOs, resetting the POPDR, and configuring the necessary pull up pull down registers for the pins. And then comes the interesting part, which is monitoring the key pressed and representing the key which is pressed on the LEDs using a binary format, and then displaying it on LCD. These three are extra steps apart from regular applications. So how we will be dealing with this is, as mentioned in the previous video, which is part 5 of this series, we will be using the same keyscan function that we have developed in the part 5, and we'll be using the same LCD driver functions that we developed in the part 6. So if anyone has missed them, please do check out part 5 and part 6, wherein I have explained how the keyscan driver is developed and how LCD drivers are developed. So enabling clock, we'll be using two ports, which is port A and port B for LCD and keypad separately. In part 5 and part 6, we have used A and B. So to combine both, I'm using A and B together this time. So we'll be using RCC AHB1 ENR, uh, that is register and clock control, and AHB1 ENR. Why specifically AHB1 ENR? If anyone have doubt regarding that, you can visit my part 2 of this series, in which I have clearly explained why to go with this particular register and why to go with this particular bus. So that will be more clear. And as mentioned, GPIO B and GPIO A ports will be we are using, and this is the model register format for any GPIO port. So our objectives for this video will be coming to how to write a value into a register. We'll always be using and equal to negation of combination for resetting the particular bits, and or equal to combination to set particular bits. So coming to the objectives, we'll be using PB, which is port B. Before going into the objectives, that is which register to be programmed, let me show you the schematic diagram so that it will be clear for you. This is the schematic that we will be using. If you observe, I have connected all the rows to PB0 to PB3 and all the columns from PB4 to PB6, and I have connected PB12 to PB15 as LEDs, similar to the one that I have done in part 5 of this series. And coming to LCD, as mentioned in the previous part, which is part 6, I have connected D0 to D7 from PA8 to PA15, and register select and enable, I have used PA0 and PA1. So this is the schematic that we will be using. So according to the schematic, we need to program PA8 to PA15 as outputs, and PB0 to PB3 as outputs, and PB12 to PB15 as outputs. So for that, first we will look at keypad interfacing, which is PB0 to PB3 we have to program them as outputs, and PB12 to PB15 we need as outputs, and remaining we need them as inputs. So first we will be resetting them, and then we will be configuring it to our desired mode. If you want to see in detail, please do visit the separate interfacing parts, which is part 5 and part 6. So coming to LCD interfacing, we will be using port A. So we need port A0 and port A1 for register select and enable pins, and port A8 to port A15 for data pins. So these we need them as outputs. So first we'll reset the model register, and then we'll configure in the pins to necessary mode. And this is the PUPDR register, which is pull up and pull down register. This register we will be using if we require pull up or pull down for any pins. So yeah, coming to configuring pull up and pull down, we'll be needing pull up and pull down only for port B, because we are interfacing keypad for port B. In port B, as we are interfacing keypad, what are the column pins that we are taking as our inputs, those we have to program as pull up, internal pull up. We have to give them as internal pull up. So we are taking first resetting the three pins, that is 6 bits, and then we are configuring the 3 pins as pull up mode. And this is the IDR, which is of 16 bits, each bit corresponding to the status of the particular pin of the port. This is ODR, which is known as output data register. Similar to IDR, here also each bit corresponds to their respective pin in the GPIO port. So coming to the KeyScan algorithm development, first we will make rows as outputs and columns as inputs. So we will reset the GPIO register, and then we'll program row the GPIO motor register such that rows will be outputs and columns will be inputs. And once that is done, what we'll be doing is we'll make all the rows as 0. That is, we'll keep 0 at each row and check for the if any of the column is becoming 0. If any of the column becomes 0, what we do is we'll make all the rows as 1 and start making them 0 one by one. That is, first we'll make 111 and then we will do 1101 and then we'll do 1011 and then comes 0111. So correspondingly what we get is this corresponding to 0x0e, and this corresponds to 0x0d, this corresponds to 0x0b, and this corresponds to 0x07. So in this manner we will be putting onto the rows, we'll be configuring the rows. And then for each row, like once we kept 1110, that is we are making row 1 as 0, what we'll do is we'll check all the columns if anything is becoming 0. When we kept row 1 as 0, if column 1 or 2 or 3 are getting 0, then we will take the corresponding position, that is R1C1 or R1C2 or R1C3, and return the corresponding value from the function. See, you can see return X. So this is what keyscan algorithm development. If you want to see in detail, you can visit my previous videos. And this is the LCD driver function. So we will be using majorly 4 functions, which are LCD print, send command, LCD init, and print str. So for LCD interfacing, we have 4 things majorly, which is we'll keep data onto the data lines, and then we'll select the register select, which is 0 for command and 1 for data. And once you have done with selecting register select, you will send a pulse on enable pin of 5 milliseconds pulse width. That is the way of sending data to LCD. So coming to LCD print function, here we deal with sending data, not the command. So first we'll left shift the data by 8 bits. Why? Because we are connecting the LCD to upper 8 bits of the port, which is from PA8 to PA15. So in order to properly program the pins, we will left shift by 8 bits so that all the data will be in the upper byte. So when you perform an normal bitwise OR operation, all the bits will be properly copied onto the pins. So after left shifting by 8 bits, we'll load the data. Loading the data is nothing but performing normal OR operation, and then we'll make the register select high because it is LCD print, which is dealing with the sending of data. So and next we'll send a pulse on enable pin. Coming to sending command, everything remains the same except that here we will be making register select as low to say to LCD that whatever the data you receive, it is not uh, actual data, it is a command, so perform accordingly. And then coming to LCD init, once we have defined send command function, we have some set of commands to be sent to LCD before starting off with sending data to print on it. So that commands are, first one is 0x38. What this command does is this command tells to the LCD that we are using LCD in 16 cross 2 mode with 5 cross 7 matrix. 5 cross 7 matrix is that you will have 5 dots in each row, like that you will have 7 rows. So this is the dot matrix that we will be using. So whatever the data you want to write or you want to print on the LCD, that will be the combination of connecting these dots only. And coming to next thing, which is 0x0f, this we will be using to display turn on the display of the LCD and then blink the cursor so that our user will be knowing where the cursor is. And coming to 0x06, it is an auto increment mode. Auto increment mode is nothing but whenever you are displaying the data, if for example if I want to print hello, then I'll send H first, then E, then L, then L and O. So whenever I'm sending H, when and once I complete sending H and then I start sending E, it should, the cursor should move increment a bit and then display it on the second cell. That is, if you have 16 cross 2 LCD, if H is coming on the first register, E should come in the second register. For the cursor to move to the second register, we can't keep on telling the cursor every time, right? So what we do is we just keep it in the auto increment mode. Whenever the data comes, it will automatically increment to the next register and display the whatever the string that we are sending or character. And next is the 0x01, which is nothing but clearing the display. And finally, this is known as print str function. In print str, what we do is, for example, if I want to print hello, I can't keep on sending h1s, e1s, l1s, l1s, and o1s. So for that, I'll define a function which is known as print str. It will directly accept hello, and it will take care of looping out through the string and sending character by character using the LCD print function internally. So this is a brief introduction about how we develop LCD driver function. So if you want it in a more detailed fashion, you can visit my part 6 of this series, which will detailedly explain about in developing LCD driver functions. So this is the keypad logic. We will be clearing the output data register, and first we'll be keeping the all the registers as 0. So when all the registers are 0, we'll be monitoring the IDR. If that is, IDR means the input data register, if any of the columns is becoming 0, 0x70 means we'll have three ones. So if nothing is becoming 0, it will all the three columns will read 1 only, as they are internally pulled up. So you will read the IDR value. If anything becomes 0, this bodiless while loop will break and it will go down. Once it goes down, you will reprogram the rows, making one row 0 at a time. And once you make a row 0, what you will do is you will read the IDR value, and if it is 0x60, so IDR value can be either 110, 101, or 011. These are the only three possible IDR values, because if a row is enabled, that is, if 0 is programmed for a row, if someone is pressing a button of that particular row, then only that particular row and column, only one position, that is Ri and Cj, so this position only becomes 0. So either only one of 0 will become 0. So this will corresponds to 6, this corresponds to 5, this corresponds to 3. So you'll monitor for that. If you get 0x60, you'll return 1, 2, 3. These values will depend on the row number. As it is a first row, I'm sending 1, 2, 3. Once you move on to the second row, you will get 4, 5, 6. Third row 7, 8, 9, and so on. This values depends on your type of keypad and what the numbers you are keeping on the keypad. Once you are done with it, we'll be moving into the LCD driver function. In LCD driver function, what we have is, we have the LCD print function, send command function, LCD init, and then printing string. So in LCD print function, what we do is, first we'll clear the output data register and left shift the data and perform an bitwise OR operation, so that we'll be loading the data onto the lines. Once the data is loaded onto the lines, we are making the register select high to tell the LCD that this is not command, this is the data. And once after that, we'll be making the enable pin high, waiting for 5 milliseconds, and then making it low. So this is the way to send data to the LCD. So coming to the send command function, we have the similar thing, just that we are making register select 0 here to tell that it is a command. And next we have LCD init. Once we have defined send command function, we'll be sending a set of commands to initialize the LCD, starting from 0x38 and ending at 0x01. We have these four major commands. If you want to know in detail about many other commands which can be sent to LCD, you can always visit my past videos. And coming to printing a string function, so here what we do is we loop around the string until the string termination character, which is \0, is received. And at every point we'll be sending the character to LCD print function to print that particular character onto the LCD. And next comes writing the scanned key value onto the LEDs and LCD. So until now, what we done is we have developed the drivers. So now we will see how we use those driver functions in our main program. So first I'm defining a character variable named key, and then I'm enabling clock to port A and port B. I'm using keypad init and LCD init functions, which will take care of initializing keypad and LCD. So coming to while one, this is a body normal embedded programs rule, that is, everything that needs to be uh, run multiple times will be kept in while one, because it needs to be continuously running, it shouldn't stop. So first line will be scanning the key is assigned with KeyScan. So we will wait here until someone presses a key. If someone presses a key, that while loop that we have internally in the driver function of the key scan will break, and the key will be read and returned from the function. So once we get the key, what we'll do is we'll first clear the output data register and left shift the value of key by 12 bits, because we have programmed that we'll be writing the value to pb 12 to pb 15. So these are the 4 bits that we will be using. These are the upper 4 bits. So we have to left shift whatever the data we get by 12 times, so that we'll be able to display it properly. And then we have some special keys, that is asterisk 0 and 11. Sorry, hashtag. So for 0, whatever what I'm returning from the keypad driver is I'm returning 10, and for asterisk I'm returning for asterisk I'm returning 11, and for hash I'm returning 12. So if you observe here, if key is equals to 11, that is if I am pressing star, I am writing here so that the my LCD will shift from first line of the 16 cross to LCD to the second line. So if this is the first line, if I am pressing star, the cursor will move to the second line. And if I am pressing hash, I am writing to send a command called as 0x01, which means I am clearing display. These are some special functions that I have assigned to my keypad, so that to make it more intuitive. And coming to key is equals to 10, if key is equals to 10, instead of directly sending, because we cannot directly send LCD print of key, because yeah, you can do that, but 10 is not a particular ASCII character. So what we do is we use print str function to send 10. Otherwise we will use ASCII values, that is we will be using LCD print function, and we'll be performing key plus 48, because 48 corresponds to ASCII value of 0. So if the key is read as 1 2 3 4, the ASCII values corresponding to that number will be 49, 50, 51, 52, and all. So what I'm doing is I'm adding the additional offset I'm getting to the ASCII value and sending it to the LCD print function. The compiler internally takes care of converting this ASCII into character while displaying it on the LCD. So this is the whole code. First you will initialize all the functions, that is you'll declare the prototypes and then define all the functions starting from ms delay, and then you'll start with key scan. Once the key scan is done, you will have the keypad in it, wherein you'll have keypad specific motor register and PUPDI register configurations. And once after that you'll have LCD drivers, and in the LCD drivers you will also have LCD in it, which will take care of initializing the LCD. Once after this, you will have a main function which will use this all the predefined functions to display whatever the character that is being pressed on the keypad onto the LED as well as onto the LCD at a time. So now let us go to the Keil µVision to see how the code is written. So as shown in the presentation, these are the function declarations, and these are the function definitions. And once after the function definitions, we have our main function. So yeah, after writing the code, you have to translate it, and after translating, you have to go to Flash, configure Flash tools, and here in configure Flash tools, you have to go to debug. Here you have to enable using simulator and go to output. You have to check the box which is named as create hex file. After that, you have to give a name to your executable. Here some random name is there, you can ignore it. You can give a name as you wish. Once you have done with it, you can click on OK and then click on build. So if you click on build, it will build a hex file in the objects folder of corresponding location. And then after this, let us move to the Proteus simulation. So this is the schematic that I have used. Just to make it look good, I have used a 1x4 LED matrix, so that instead of keeping 4 LEDs normally, I have kept it like this. You can double click on this and load your hex file. I have already loaded it, which is keypad underscore LCD driver. So click on OK, and then run the simulation. You can see the display is turned on and cursor is blinking because we have sent a command called 0x0f. And then let me press 8. So 8 is getting printed. 7 9 0 0 is not printed because I'm sending 10 in the place of 0. So yeah, and 1, 2, 3. So for example, if I want to clear the display, I can press hash and 8, 5, 6. If I want to print the remaining numbers in the next line, I can press star and move to the next line and print them in the next line. And you can also see whatever I'm pressing here, it is being reflected on the 1 cross 4 LED matrix. So 2 is corresponding to 1 0, and 5 is corresponding to 0 1 0 1, and 8 corresponds to 1 0 0 0. So this is all about the interfacing of keypad and LCD together with STM32. So if you find this video informative and useful, please do share this video with your friends and like the video. If you have any doubts, please let me know in the comment section. And all the codes and documentation that I have used in this video, I have converted into a repository and shared the repository link in the description. Please do check it out. And for more such interesting videos, please do subscribe to Tech Talks. Thank you.